Dr. Nigel Fraser. What a great honor. So you'd like to hear a little bit about my work? Sure thing. But first, I would like to thank Dr. Nigel Fraser and the nominating committee for this prestigious award. Now, on to the work. Here I share some of my graduate work. Viruses are all around us. The field of virology arguably started in 1892 with the first discovered virus, the tobacco mosaic virus. It took until 1976 for the first genome to be sequenced, coincidentally also a virus. In December of 2019, the first reports of a respiratory outbreak were identified. It took only 10 days for the SARS-CoV-2 genome to be published. Once published, we learned several things. Not just that SARS-CoV-2 was the causative agent of COVID-19, a disease which would claim more than 6 million lives, but also that SARS-CoV-2 was a beta coronavirus with genome size approximately 30,000 nucleotides, and it had a single-stranded RNA genome. This meant that rapid mutations may be expected. Successive waves of SARS-CoV-2 variants were identified, as one variant replaced a previous variant. And when we took the number of mutations over a given amount of time, the slope gives us the evolution rate. Each variant had an evolution rate, but when we transitioned from one variant to the next, there were these genetic jumps, and these jumps became an area of great interest. Several mechanisms were proposed, and these include unsampled human reservoirs, also zoonotic spillovers and spillbacks, and immunocompromised prolonged infections. In my graduate work, we addressed components of each of these. When we looked at the population scale, we asked how do partially vaccinated populations affect circulating strains of SARS-CoV-2? We sequenced 2,600 isolates in the Philadelphia area, and what we found was in individuals that were vaccinated, there was an enrichment of the newly emergent Delta strain B.1.617.2. We also found that substitutions associated with immune evasion were enriched in the vaccinated population. When we looked at zoonotic spillovers and spillbacks, we sampled 1,500 retropharyngeal lymph nodes, and we sequenced SARS-CoV-2. And we not only found a high prevalence of SARS-CoV-2 in the deer, but also that alpha and delta strains persisted for months to years after they stopped circulating in humans. Not only that, but alpha and delta strains that were identified were highly divergent from their nearest human neighbors. However, evolution rates were similar to those in human-to-human transmission. When we looked at immunocompromised prolonged infections, what we found were several interesting facts. One, that within host evolution rates in immunocompromised individuals could be much greater than that of the person-to-person transmission of the background, but also that individuals that had received monoclonal antibodies led to the rapid gain of drug-resistant substitutions. So where does that leave us? There may not be one hypothesis which explains where all variants emerge. However, each has some degree of validity, and immunocompromised prolonged infections result in meaningful substitutions in a very short period of time. And with that, I'd like to thank not only the contributors to this research, but also the Bushman Lab, Rick Bushman, the Department of Microbiology, and the nominating committee for the Fraser Prize.